This lesson is on how to find the greatest common factor. If you are not familiar with what a factor is, that's something that you're definitely going to need to know before we begin this lesson, because we are dealing with really just factors and factors of more than one number. If we're talking about greatest common factor, the first thing that we're going to do is review factors. My two examples that I'm going to give you to start with will be the number 30 and the number 45. And what I'm going to do is I'm going to list out all the factors of 30 and all the factors of 45. You'll notice that there are some things that both 30 and 45 have in common. And right here I see that these all have 1. These have 3. We have a lot of factors that they have in common. And when we're talking about finding the greatest common factor, we talk about finding of all of these numbers here, which one is the highest number. So we would say that the greatest common factor, and from now on we're going to say GCF of 30 and 45 is 15. That is their greatest common factor. Now, this was fine and all because we are able to see what the greatest common factor is by listing out all of the factors. But there's another way that will help us find the greatest common factor, which deals with the factor trees that I had already talked about in a previous lesson. I'm going to give you an example of two numbers. In this case, we're going to keep the number 45 and 60. So now we're going to make a prime factor tree for each of these. And the reason being is because I'm just going to show you a cool trick where you can find the GCF of several numbers besides having to list out all of their factors. It starts off by making a factor tree, so I'm going to divide 45 into 9 and 5, and then I'm going to keep going down here and do 3 and 3 so that now I have my prime factors. Now we're going to do 60, so 60 I'm going to divide into 2 and 30. The 30 I'm going to switch into a 15 and a 2, and the 2 is just hanging out. Then the 2 I'm going to bring here. This is going to be 3, this is going to be 5, and this 2, and they're being multiplied together. So here are the factors, the prime factors of 45 and the prime factors of 60. To find the greatest common factor, the first step is to find the prime factors. That's the first step. The second step is find all the prime factors in common. Find all common prime. And the third step would be, if I look here at the prime factors of 45 and I look here at the prime factors, the only ones that they have in common are 3 and 5. And if I do 3 times 5, it equals to 15, and that is the GCF of 45 and 60. It gets a little bit more complicated when we see several common prime factors and several common repetition of those prime factors. So here's another example where things get a little bit more complex. The numbers that I'm going to pick here will be 96, 144, and 240. So I'm going to quickly show you what each of these prime factors turns into. Alright, so I have made the prime factor trees here for 96, 144, and 240. Now that was our step 1. Always step 1 was to find the prime factors. Step 2 was to find all the common prime factors. Common to all of these are just 3 and 2. Okay, those are the only common factor or common prime factors. This 5 is all alone. The third step that I told you in the last slide was so this was step 2. The third step that I told you to do is multiply all of the common prime factors. So I would assume that you would think that, I would just do 3 times 2. But that's not the case. And this is the best way that I can think of explaining it over the years to students. What you're going to do is, even though it's called the greatest common factor, you're actually going to find the common prime factors, which in our case are 2 and 3, and you're going to, in the exponent, of the 2 and the 3 put in the least amount of times that you see them in a tree. So I see a 3 only show up here once. I see a 3 show up here twice. And I see a 3 show up here once. So the least amount of times that I see a 3 is 1 time. So in the exponent position, I'm going to put a 1. And then I'm going to count the lowest amount of times that I see a 2. So in the first tree, I see a 2 1, 2, 3, 4, 5 times. So let's see if there's something that shows up least amount of times. 1, 2, 3, 4. Okay, already that's lesser than 5, so it might be 4. And this one has 1, 2, 3. So because this one has 3, it's the lowest amount of times that we see it in a tree. So our 2 is going to be to the power of 3. And then you're going to multiply those together, not just the prime factors, but those together. When you multiply 2 to the power of 3 times 3, the greatest common factor is going to be 24. That's basically the best way to do greatest common factor. Remember that for step 3, you're actually going to find the least amount of times in the tree and then put as exponent, multiply, because that's what we did. So that is the prime factor trick for finding the greatest common factor, as opposed to what I did here, listing them all out and circling them. This is the best way, especially when we're dealing with huge numbers and several numbers like 96, 144, and 240.